So welcome to the third session of the series Decoding AI. And today we will be discussing machine learning for text analysis. So let's start with the session. And before that, do you have any questions from the previous session? So if you have any questions, just type in the chat box so that I'll be able to respond you. Okay, so let's start with, so I'm assuming there are no questions. So let's start with today's class, and that is machine learning for text analysis. Okay. So this is a continuation of what we discussed in the first class when I introduced machine learning and artificial intelligence concepts. So in that class, I mentioned the different applications of machine learning, and text analysis is one of those applications. So we will be discussing this in detail. We will not go into the different algorithms. I'll introduce the algorithms which are used for machine learning text analysis, but we will not be going into too much detail. But you are free to ask me if you want to learn it more or if you want to go into detail. So today's class, we will be, these are the objectives of today's class. First, I'll introduce what exactly is meant by text analysis, what are the different components, and what exactly we achieve by doing text analysis. And then you will learn different ways to clean and prepare text for analysis, because it's not as simple as cleaning or preparing the data when you do the data analysis, that is numerical data. And then you will see that how we can, by different processing steps, how we can get insights from the text itself. And we will be doing programming. And I have 2 or 3 files which we will be going through all the steps of how to get the different insights. And then I'll show you a demo that what are the different things you can achieve by doing text analysis. And there will be a student presentation. So this is the layout of today's class. So let's start with the most basic question, and that is, what exactly is text analysis? Text analysis is when you automate the process and use AI to obtain information from the text. So text is basically what the different words we speak, or if something is written, a book is written. So what we are trying to do, it's a collection of words, and we want to get some information. Why is it important? So basically, it's important because nowadays you cannot collect data on by surveying each and every person, but because of the social media, and there are different platforms where you can use words to give comments or feedback, or you can express your emotions. So basically, that is why this field of text analysis just evolved immensely. And one of the examples is that you cannot, with so much data available, it's not always possible to look at the comments or feedbacks of each and every person. So this is the best way where you can just analyze the data which is available everywhere, from social media, from different responses, reviews. And then from that, you do all kind of analysis and then find out what exactly is this, the overall intent or overall feedback of the product if you are doing a product analysis. So there are different categories where you can do it, and tweets, emails, product reviews, and then complaints. So, for example, Google processes around 3.5 billion searches per day. And then if they want to give on their website, if they in the analytics side, if they want to show people that, okay, what kind of searches are being made in a particular day, or what are the different things people are searching. And these kind of analytics is basically, it's not feasible unless and until you have some algorithms or some mechanism to sort that information. And that was exactly is text analysis. So the text analysis is basically has several steps. And first is you pre-process the data. Now, if you have attended the data analysis class, you know that first of all, you have to prepare your data for analysis, because you cannot just take the data due to a lot of problems or a lot of noise in the data. So you cannot just directly take it and start analyzing. So first we have to prepare our data. And these are some of the pre-processing steps. In numerical data, we generally handle the missing data, or we try to clean, or these were the pre-processing steps. But in text analysis, we have different kind of steps, which we'll go through. And then second step is feature extraction. So if you are trying to categorize or classify your data, so we want to see what exactly are we trying to do, whether it's a classification problem, association problem. And that is what we do in feature extraction. And a lot of uh, math goes into it. So we will be, I will show you example. I will show you, I will show the different steps where we do a problem, text analysis problem end to end using machine learning. But definitely we will not go into too much details, because there are so many things that goes into this in this step. And then third is choosing machine learning algorithms. So in text analysis, we have different kind of algorithms, and there are no fixed rules of choosing algorithm. You just have to make sure that whatever algorithm you are using, how accurate is that algorithm, and that is a criteria. That is a criteria which we use when we decide on an algorithm. That okay, my finally I will choose this model which comes from that particular application of algorithm. So that is why it a lot of experience goes into choosing the algorithms. And luckily you don't have to design the algorithms, but because they are already there. But final decision is totally depends on how accurate results are you getting. Okay, so that is where you will see it becomes complex process. So step 2 and step 3 are really complex process, but definitely I'll show you one example so you will get at least a feel of how exactly is machine learning applied in a text analysis. Okay, so let me introduce this package, which is NLTK, and it's a Python package or library, which we call, and it's called Natural Language Toolkit, NLTK package. You will be using it for all the text pre-processing, and we will be using scikit, SCIKIT, which is again a Python package for machine learning. So these two are the main libraries or packages which are used for doing text analysis. So why this is a very important and very popular text analysis tool? Because it's very easy to use it. It has a lot of, you can say, functionalities, and it supports a lot of languages. It supports a lot of words and dictionaries. So that is why, and it's also free. And you don't have to work hard to incorporate NLTK into your program. So That is something which is worth exploring. We will be doing NLTK for pre-processing, and you will really appreciate it, because very complex tasks can be just be done by one line or two line of codes. So it's already there. You just have to import it in your program, and then you start using it. And these are the different uh, functions, or these are the different jobs you can get it done. One is classification, and then tokenization. I will go through everything when we do the programming. And then a lot of how to clean your data, how to make it your data more relevant and ready for analysis. So text pre-processing. So basically, text pre-processing is a step which is done before you start applying your machine learning algorithms. And you will see that many of the text insights start coming even from when you do pre-processing. And even if you don't go up to that part where you start applying algorithms and try to predict your make a model, try to predict your text analysis results, you can even get some good results just by pre-processing, using the pre-processing steps. And we will see that how they can be done. So if you are planning to do some text analysis, but you don't want to go into that advanced level, definitely you can do it. So it's not mandatory that, okay, when you start doing text analysis, you have to start from pre-processing and then you have to apply the algorithms and then get a model, start predicting. No, you don't have to do it. So what we are going to do, I'll show you some examples where you can just, while looking at doing the pre-processing part, you can do a lot of things about the text which you have been given. So even with these basic steps, you can get some really good results. So this is pre-processing. After the text is obtained, we start text normalization. And text normalization are the different steps. They are not, it's not a comprehensive list. You can do a lot of other things also, but mainly, there are some things which we do almost for every kind of text. And then it's one of those is converting all letters of your text to either upper or lower case, so that it brings uniformity in your text. Then we try to get rid of unnecessary information. So depending on the kind of text or depending on the objective of your analysis, it's quite, you may want to remove some unnecessary information. So you may want to remove some unnecessary words or numbers from your whatever is the given text. Then you may want to remove the punctuations because they don't add anything to your analysis. Or you may want to add some other things. So right now we will take us in our programming assignment, we'll take a very simple text, which is, it's not a very complex text, but definitely we will use all these things. Then if your text has, you can remove white spaces, you can expand abbreviations, and then you can remove stop words or terms which are not relevant to your analysis, or you may want to remove some specific words. Then you have to uh, tell your whatever pre-processing you are doing, you may want to add those words. So there are some things which you will get default from your NLTK library. But if you want to be very specific, you can add your constraints also. Okay, so today we are in our class, we will not be adding too many constraints. We'll just use whatever default things are given by NLTK. Okay, so these are, I have given you examples, and I have also given you the programs. Now I will do the same programs. I will run it on Jupyter Notebook. So right now I'm just explaining it. I will explain it one more time when we do it on a Jupyter Notebook. So what exactly are we doing? In this left-hand side program, we are converting the whatever is the input text, we are converting it to the whole text into lowercase. And the function to do this is so the function to do is dot lower. Now we have not yet started doing the using the NLTK library. Dot lower and dot upper are the functions available in your default string with default string libraries. So you don't have to you don't have to import any extra package, or you don't have to import any extra libraries, because they are some of the very simple functions. So you can just right away call them directly in your program. So what exactly is there is an input string, and the input string is the three biggest countries by population in 2017 are China, India, and United States. Now, as you can see, my input string has both the cases, both lower and upper cases. I want to convert this whole string into lowercase. Okay. So what I did was the name of the string. So input string, this whole text is saved in a variable which is called input string. Okay. And then what did I do? I did input str, the name of the string, and then I called a function dot lower. So if you recall, we generally, whenever we are calling a function from any library, we just use this dot to call the function. Mostly it's like that. And then we say lower. So just a single line is going to, and then I am saving the new result in again in the same variable. So what happens? In this first step, I am saving it in variable name input str. And then this gets overridden because I converted into lower. And then I am saving it again with the same name. You may use another name. But since we don't want this initial string, we don't, we will not be using it again. So I'm just getting rid of it. So I can reuse the variable name. So if I reuse the variable name, then what happens? The earlier value is overridden. Okay, so overwritten. So we overwrite this earlier value with the new value. And now I am printing. So print, and then a parenthesis and variable name. So if I want to print a variable, I don't use a quote. But if I want to print a sentence, I will use a quote. Because if you remember in the last class when we started with Python programming, we said that Python has three types of variables, and a string variables is written with double quotes or inside single quote. I could have used the single quote also. Okay, so it's totally up to you whether you want to use the double quotes or you want to use the single. Now, okay. Now this is the second example is we are doing the same thing. Now we want to convert it into the whole string into upper. So I'm calling this function dot upper. So instead of dot lower, I'm calling the same function, and we are going to the way it is done, the way the flow of program is similar to this. Okay, so just now the upper will convert whole string into uppercase. So when we pre-process, the first thing we do is we either convert the whole text into lowercase or whole text into uppercase. Generally, we convert it into lowercase because, you know, It saves us a lot of trouble and errors which can arise due to the mixed case situation. So that is why we don't want to use them. And then next is removing numbers. We may want to remove numbers if they are not relevant to our analysis. Okay. So, and then regular expressions. Now, this is something which is Python library. We have not covered it. It's a Python library, and regular expressions, the library is RE, and regular expressions are very important when we want to do string matching or finding patterns in the given string. So if you are planning to do text analysis for your projects, or if you want to really want to do some um, and take some data and then work on it, then I would recommend that you please go through the regular expressions chapter and learn it, because this will be very useful when you are doing the text analysis. And one of the example is if you want to remove this these numbers. Okay. So in this sentence, we are not very interested because the number 3 and 5 and 4 are not adding too much information. We may want to get rid of it. So we are going to use this. And this is a syntax which comes from regular expressions. So you may want to find a subset, and you may want to just remove these numbers. So we have used regular expressions to remove numbers. Okay. So now if you run this program, you will get a string which doesn't contain the numbers. Okay. So this is how we remove it. Now, when we do programming, it's not compulsory that you have just one way of writing your program. There are several ways of achieving the same output. Okay. So you have to, by experience and by doing a lot of programming, you have to find out which will be the least amount of code is required. So what method should you be using which requires the least amount of code? So don't think that this is the only way it can be achieved. Okay. So you can explore more ways. Then tokenization and removing stop words. Now we will start using NLTK. And tokenization is a process. So suppose I give you this sentence, I like Python. So what tokenization does? Tokenization splits the whole sentence into different words. Okay. And then stores it in a data structure which is called a list. So if I tokenize this, it will be something like this. Okay. So it will be a list, or you can say in other words, it will be a group of words which are basically split into individual values. So tokenization is a very nice process because, then it uh, gives you a lot of flexibility, and you can do this text analysis very easily. So just the splitting of your sentence into individual words or in smaller pieces, which are called tokens. So basically now my sentence is split into 3 tokens. Token one is I, token 2 is like, and token 3 is like. Okay. And the base, so the tokenization process doesn't distinguish between words or special characters or punctuations or anything else. So if I say I like Python, comma, and then I say, sorry, let me, Okay, now if I say I like Python and comma, not Java. So my tokenization process, what will it do? My tokenization process will make, it will give a token to comma also. So it doesn't distinguish between if it is a word or it's a punctuation or it's something else or it's it doesn't take into consideration the spaces, but it uh, just splits each and every string into a token. So even a punctuation will be a token. So that's why it's always good idea to remove unnecessary information from your text. Now stop words. So there are some words in English which doesn't add any information, any useful information. And the words are the, a, an, is, am, are. They don't add information for the analysis. So they are basically, and they are most common used. So what we do, we call them stop words. These are called stop words. And then these stop words are removed. So when you remove these stop words, you will see a lot of your, a huge data just reduces into a small data set. Because these words are not adding anything very meaningful. And for stop words removal, for tokenization, we use NLTK. It's called Natural Language Toolkit. So this is another pre-processing step. And this is the code for stop word removal. We will, there is something called, so first we have to, now since we have to use NLTK. So I will tell you how the step one will be to basically install NLTK because NLTK doesn't come by default. The first thing is install NLTK. And the next thing is you have to import NLTK. So depending on the usage of which package you, which different functionality you want to achieve, you import different packages. And to tokenize, we import word underscore tokenize. And then for removing the stop words, there is a whole library of stop words. So you don't have to give any word stop words. There is a default library in Python, which is a part of NLTK package, and it's called stop words. You just have to match your text to that library and it will find out and remove it. So this is something very interesting. So I have input a string, which is NLTK is a leading platform for building Python programs, and it's English. And then I say, okay, there is a library which is stop words, and it's English words. So the library is in English. Okay, so because we are dealing with English language and we want all the stop words to be taken from English language. So there is already a library there. And then in this step, we are splitting our input string into tokens. And then we are using a for loop. Now, we have not, I had just mentioned what exactly for loops do. If we want to do the same thing again and again, we use for loops and while loops. And for is a very easy loop. And so there are ways, which is called syntax. There is a specific way of writing it. And this is a short form of writing a for loop. So what exactly are we achieving in this line? We are trying to match each and every token to the list of stop words. Okay. So we are basically matching. So suppose we had, this is our tokens. And this is our list of stop words. So this is my token one, let's say token two, token three. So I will take token one and I will match to all the stop words. See if my token one is in the stop words list. If it is there, I'm going to remove it. If not, then I'm going to keep it. So basically now that is where I'm storing my result. So my result will contain the list of all the tokens which are not in a stop, which are not in a stop words, which are not stop words basically. So the final result which I'm getting, it will get rid of all the stop words. So you just have to know the right functions which you have to call. You have to know the right libraries which you have to call. Rest can be done in just one line. So the most important thing in text analysis or any kind of analysis is you have to know, especially I would say that it is becomes very important in text analysis because there are so many libraries and you have to find out what are the correct imports you have to do. And you will see when we are doing the programming that we, for each and every task we want to achieve, we have to import one library. So these are the things, and libraries are imported just once in your program. Okay. The installation of a library is done just once in your whole session. So suppose if you are using a Jupyter on your machine, so you just import it once, you are done with it. But if you are using it on Binder, I'm sure you will have to use it each and every time. So since I have it in my machine, so I will show you how you install it and then how you import it. But import is always done once in a program. And if you write a different program, then you have to import it again. You don't have to install the program again, but you have to import your, sorry, you don't have to install your package or library every time, but you have to import different packages or modules every one time in every program. So you have to make sure. So for if I make 3 programs and my 3 programs are doing data analysis, I have to import them in each and every file. Let's So these are the token, output of the token. And since we have removed the stop words were in this particular input string is a, for, to, with. These were the stop words which were removed. So if you see the output, the final output, you can see that this is not there, this is not there, this is not there, this is not there, and so on. So we in the step one, we tokenized our text, and in step two, we just removed the stop words. Okay, now stemming. Stemming is basically reducing a word because it's quite possible that a word is used in different forms. Okay, now, so stemming, what it does, it reduces the word into base form and just get rid of the extra alphabets. You can say that. So in books or in looks or looked, it just got rid of this and it got rid of this. So sometimes stemming is also becomes very relevant because if you say that if you're talking about a swimming, so it's quite possible that in your text, once it's the words swim, swimming, and swimmer are used. Now all three are related with swim. So stemming just takes care of the fact that it gets rid of, in swimmer, it gets rid of ER or MER. And in swimming, it just gets rid of ING. Okay, so that is how it is done. So we have to again import some packages, we have to download some, and this is called stemmer. So we have to, from NLTK, we have to uh, import this particular package. Now, this is a correct syntax. This is how you have to use it. So make sure if you miss any of these things, then your program is not going to work. So this is the way it is imported. And this is the example. We are using a stemmer. And input string is, there are several types of stemming algorithms. And then again, you do the tokenization and then you stem it. And as you can see, it just gets rid, it's just gets rid of, in stemming, it gets rid of MING, and in several, it gets rid of. Okay, so that this is how it is done. So let's recap on, okay, let me take you to the programming. So let's do whatever we have, you have seen the different steps of pre-processing. Let's program it, and then we'll come back to this. So let's do. Now I think you need this file, so I will give this file. I'll copy and paste it on your chat box. Just give me a second. Okay. Now, how you have to save this file in your desktop, and since we will be using a Jupyter Online, so you can see my screen. So let's again do Jupyter Online, because you have to need a Jupyter notebook to open this file. So we'll do Jupyter Online, and then this is first try Jupyter, try classic notebook, and let it start. So you can do with me, start a Jupyter notebook so that you can upload this file. Now, if you see file and you do open notebook, and if you go to the right hand side, top upload, and then you go, this is the file which I have given, and it must be, if you have saved it on your desktop, just click this file, machine learning text analysis basics, and then open it. You will see there is something called upload, click upload, and then you can open it. Okay. So have you all been able to open it? Can we go ahead with programming? Yes, no, maybe. Okay, I'm assuming that everybody could manage to open this file and there's no problem. So let's start with the first. Let's start. Okay. You don't see it in the chat. Okay, let me do it one more time. Yeah, it must be. Can you see it now? So first thing is we are converting it into a lowercase. So now you can see. Now you can see the string is given in red. It has turned red. So whenever you write it in Jupyter Notebook, you will see there's a color change. You can see there is a comment there. So first line, I have given a comment to make uh, to help me understand what exactly is being done. And then I am writing this. Now, make sure in the last class, I told you that Python is case sensitive as well as Python is uh, indentation sensitive. So if you change the position of any line, then it's going to give you error. So if I make it like this, then run it, it says indentation error. Okay, unexpected indent. So you have to make sure the indentation is correct because Python organizes the code based on the indentation. So if he sees that, okay, it's not making sense, then it's definitely going to give you error because it wants to keep a block of code at one place. So we have already discussed the code, and if I run it now, I get everything is converted into lowercase. The three biggest countries by population are this. Similarly, I'm going to use, so these are simple examples, and you now are converting into uppercase. So this is done. Remove numbers. So we have already discussed what exactly is done here. We are using regular expressions, so I'm not, I won't take too much time on this. And if I run it, so it removes all the numbers. Now, if you remember this, last time I explained in detail what exactly, how does the Jupyter Notebook work. So you write, these rectangular boxes are called cells. You write your program there. And then on the top ribbon, on the top, you can say menu bar, you can see a lot of icons are there, and there is something called run. It's quite possible that in your Jupyter Notebook, it's not written run, but the icon is there. So each and every cell, when you have written the program, you will say run. Okay, and then you get the output. So I'm running cell by cell from starting. This becomes very important when you are importing any files or if you are importing any packages. This becomes really important because if you add any cell in between and then start importing packages there, it's quite possible you forget to run it. So it's always a good practice that you import all the necessary packages at the top of your program. Right now, since we are not doing it, so you will see that I have done it in between. It's not wrong to call them in between, but sometimes you just forget to run the program. So make sure if you are adding anything in between or making any changes in between your program, don't forget to run it. Otherwise, Python just keeps the previous values or previous instance of that particular cell, and it may start giving you errors. Okay, so run each cell. So now in this, yeah, I didn't do this removing punctuation. I'm going to increase the font. So what exactly is, I gave a text. I gave a text and now I want to remove all the punctuations. So what am I doing? So this is a text which has a lot of punctuations as a sample text. And what am I doing? I'm using a for loop, because what is the logic behind removing the punctuation? You want your counter to traverse each alphabet. So in this, you want your counter to come to T, to come to H, to come to I, to come to S, and see if one of them is a punctuation. So basically, how is my for loop working? I have given in my for loop, X is my counter. So counter is something which takes value in each loop. Okay. So for each loop, my counter takes different values and it is matching. So string dot punctuation. A string dot punctuation is a library, or you can say it's a set which contains all the list of punctuations, and this star, question mark, and so on. Now first X will go to the first element of this string, which is T, and then tries to match it with the whole set. If it doesn't find a match, it will keep that character as it is. Now, what am I doing here? I am saying first you traverse to string dot punctuation. First you traverse to a string dot punctuation and see if you find a match. You are going to replace it with a empty sign. Okay, so you are going to replace all the punctuations with blank space. That is what my program is doing. And that is the best way of removing punctuations. So the X is going to take all these values and check it with a string dot punctuation set. And if it finds a match, it's going to replace the punctuation with a white space or a blank. So this whole program is done to achieve. So basically now if I run this program, and I would suggest that whatever Jupyter notebooks I give to you, you can make changes to that, try to play with those notebooks and see, that will help you in understanding more. Next is tokenization and stop words removal. Since we are tokenizing, so we are using this word underscore tokenize and stop words. So we are using these two libraries, and the example is the same example. I've tokenized in this line, and then I printed the result. So in this, I am not only tokenizing it, I am also doing the stop words removal. So my final result is what we have seen in the slides. But as you can see in this particular example, I have not removed the punctuation. So my term punctuation becomes another token. Okay. So, so that is why stop words removal, before stop words removal or before tokenization, it's a good practice that you remove all the punctuations. So this is done. And then we do the stemming. So we have already seen this. Now import NLTK POTUS. For this, using the stemming algorithm, you have to download one package, and that is called punked. So these are some of the requirements which you should make sure that you fulfill. Otherwise, you are going to get a lot of errors. And dates is something which I have not discussed in the slides, but it is something which is very interesting. And the interesting is it reduces the words into its common base form. So, like if it is, uh, you can say walk. Let me give you an example. Now, if you say the actual word is mouse and its plural is mice, it encounters mice and then it reduces it to its original base form, and that is mouse. So lemmatization is the process. It's like stemming, but stemming just get rid of the unnecessary words, you can say characters, but it actually reduces into the common base form. So it's different from stemming in the way that it doesn't chop off the unnecessary alphabets while reducing it to its base form. Okay, so rather than it uses the dictionary words. So for this, we need something called lemmatizer, word lemmatizer. So we need another package, new package, and then you have seen this word underscore tokenize. You have already done it. We don't even need this because we have already imported in the previous example. So we don't have to do it twice in the same file. So the input string is bean had done languages, cities, mice. It's basically a group of words which may not seem look meaningful to you, but it's a group of words. So the first step is tokenizing it, and then you use this lemmatize function from lemmatizer. And as you can see, the result is been, had, done. So it has not changed into do, but it has changed city and mice to the original form. Okay. So this is, I found it interesting. Then there is something called named entity recognition. Now this uh, analysis is basically we are taking it one step ahead. So from the simple things, we are taking it to something complex. It's not the end. You can do a lot more things and parts of speech tagging. This is another thing which you can do. Named entity recognition, because if you use it, it's able to identify whether it's a place or a person or an organization. So named entity recognition, it's useful, especially if you want to know where exactly, suppose you are doing some query on Twitter. So you want to know where exactly the query, uh, where exactly the tweets are originating, if you want to know the location. So it's quite possible if a location is mentioned in your text, it recognizes it by using the named entity recognition functions or library. So if you want to know more, you can feel free. I have given the links. And there are several other things, but they are rather complex. So we are leaving it here only, but you can explore it. So this was the basic, which just to give you an idea what are the different tools you can use for analysis. Now I'm going to apply all these things in actual text file. Okay, and this is our second red. Yes, this is our second program, and I want you. Most of the things will look familiar to you, but this is actually analysis example where we are going to get some very interesting information from the input file. So let me share it with you in the chat box. So I'm going to, again, I'm going to give you not only the file, I'm going to give you the text file also. Just give me a second. So this is the file. And I'm going to give you the data file also. So there was a project Gutenberg. It's basically the project Gutenberg is a collection of books in a library. And this is a full-fledged text analysis project. That's what that we will be doing. And I have taken a file of, which is a collection of Shakespeare plays, and it's a text file, and I downloaded it from there. And the book is Romeo and Juliet, and we are going to do text analysis on Romeo and Juliet. So for this particular example, what are the different objectives? The different objectives are regarding this file is, we want to know how many words are there, and we want to know, we will remove a stop words. We are going to find the top 10 words used in that particular book. Now, this is not actually the actual book, but it is downloaded from Project Gutenberg, and it gives you, it may contain some extra words also. So feel free to look at the book, the text file which I have opened, because they have given you some starting some description of the book, and then it has some ending about Project Gutenberg's. A lot of extra information is also given. So what we are trying to do with this Jupyter notebook, you will learn how to basically upload a text file. And if I get the time to show you how to upload a PDF file, I can do that. But if I don't get the chance, you can always send me an email. There are ways to upload a PDF file also and do the text analysis. So in this, we are going to, so first thing you will learn how to upload a text file, because in real life, the text which you are going to analyze will not be a single line text. Okay, so you should be saving in a text file, and then you may want to upload it here in your program and then do the analysis. So that is what we are going to learn. So I have, as you can see, there are several packages which we are importing. Now, one thing which I have not shown it to you is how you are going to install an LTK package. And the way to do is, in a Jupyter notebook, you do pip install, and then you give the package name. And if you run it, it's going to take some time. But since I have already, it's already downloaded in my, it's already installed in my, with my Anaconda, and it's already there. So it's saying requirement already satisfied. But if you're doing it for the first time, this is the way you have to install any new package in Jupyter Notebook. Okay. So I'm not sure if you have to do it in Binder. I think you have to do it in Binder. So now when I have installed my package, I'm going to import them in my program. And then I will require download all the necessary files. So I'm going to use NLTK download. So you need all these files when you are doing text analysis, especially if you want to remove the stop words. Then we are going to import two another modules, which are for one for tokenizing and the other is for finding the frequency distribution. So basically, when you want to find the, let's say I want to find the top most frequent words in my text, or if I want to find what are the top 10 words, then I will be using this module frec dist. So that is why I have already imported everything at the top. Now, if you don't know what exactly you have to import, you can always add later, depending on that kind of analysis you want to do. You can always add later and then run it. So I'm running it. So it's already there. So it's saying, okay, now we have already I had already shown it to you how to convert it into lower. So I'm leaving it. Now, this is the way you upload a text file. So you are going to define a function. So I'm going to define a function in Python, which is read book. And then it takes as input the title of the book. Okay. And then there are some commands. So basically you have to open the file in read mode and then read the file, next line. And then in the third line, what you are going to do. So the book is in the, whatever text you have got, it must be in the paragraphs, line 1, line 2, line 3, line 4, and so on. So what exactly is it doing? It is now /n is for new line character. So this line ends here. So Python encounters a /n for the new line. Now I'm just saying that read the whole text as one big chunk. Okay, so remove all these new line characters and start reading it from here. Replace the new line characters with a blank space. Okay, so basically it's like if I write, if I am giving input of 10 or 100 lines in just one input. So why we are doing it? Because we want for the whole text file to be in the form of just one text input. So this is the place where I read the file and I saved. So I made this function and I'm saving it in a variable, and the variable is called text. Okay. Now what I do, I call this function and as an input, I give the name of the actual file which I want to read. And in our case, it's Romeo and Juliet.txt, which I've already shared with you on the chat box. So now I want to know what exactly has my program worked? Did my program read it correctly? So I'm going to print this. Now this is, I might have printed the first few lines, but I just want to see it. This is not a good idea if your text is a million lines. Okay, so then it may not be a good idea. So then you may want to print the first few lines. Otherwise, you can try to do it. Now, as you can see, there are some punctuations, spaces, and then it's already converted into lowercase, so we don't have to worry about it. So these are the pre-processing steps. So now I see that my file is read correctly. So I want to proceed further and then do another pre-processing step is to replace all the punctuations by a blank space. Okay. So now you can see this was the same program which I have shown you earlier. So the same code, and I am using, so I am giving, so the whole text is saved in text, and now I'm using the same code. So as you can see, now after removing punctuation, I again printed my text, and that is what you can see. You can see a lot of blank spaces. So basically that's where your text just got rid of all the punctuation marks. Okay, so you can see. So I want to know how many words are there in my text after removing punctuation. So basically it's not, it's giving me the number of characters. Okay, it's giving me, when I say len gives the length. So I'm getting the number of characters in my text. So it's 169, close to 170,000 or 169,000. So total number of, not the words, but text. And let's now, next step is break my text into tokens, because now I want to actually do a processing and I want to explore further. So tokenize the same code which I have used. Now I am tokenizing it and I'm converting into lower if I have not done previously. Okay. So convert it into lower. If I want, I can print the tokens, but it's a huge number. And then after tokenizing, I am just getting rid of the stop words. So I am using the same code which we went through earlier. And you can see that A is a set of stop words, of English stop words. And then I am printing my text without stop words. And whatever text I have obtained without stop words, I have now saved into no underscore stop words. Now you can see that we got rid of so many words like to, the. So if you take a look at this result, after removing stop words, you don't see any stop words. Okay? There are no stop words there. So we got rid of them. Now let's find the length, and you can see it's 16,149. Now this is something different because now my whole text is tokenized, and each word represents, or each punctuation represents one token. So we already got rid of punctuations. So that means there are no punctuations, and we got rid of the stop words. So basically, when we just filtered our data, so we are left with 16,149. So you can see from initially from a big data, from a big text, we have reduced it into a very small data set. So that is very important. Now let's find the frequency of the tokens. So what I did, I started with, now I'm going to do all the processing or all the analysis on the data set, which is a filtered data set, and which is this no stop words data set. Okay. So I am finding the frequency distribution. Frequency distribution, it will give me all the tokens. It will tell me that, okay, what is the frequency of each token in my data set. And since data set has so many words and it will be a long list, I just want to find the top 10 words. And the function to do is most common 10. Okay. So function is most common 10. And so it's going to, and then I printed the I'm again using a two for loops, and I'm going to save this, because when I see top 10 words, I am getting a pair of entries, where first entry is the name of, is exactly the token, okay? And the other is the frequency of that token. So from this list, you can see thou is the word that comes maximum number of times, that is 278. And the 10th in this top 10 list, come is the word that comes 99 times. That means its frequency is really high. So what I did was I wanted to make a graph of it. I wanted to have a bar chart of this frequency distribution. So for that, I wanted this to become my X list. So all the first elements of this pair, I want them to be stored in list X. And all the numbers I want to be stored in list Y. Let me do this. So I'm doing this. This is not a pre-processing step, but I'm doing this because I wanted to make a graph. So this is something which I got. And I'm going to save all the first elements of this particular pair in X and numbers in Y. Okay. And this is a shortcut of achieving this. So now when I do this and I save them in two different lists, I'm fine with it. So I printed the separate list. So as you can see, the words are and their frequency is separated. And then it's a piece of cake, because for bar chart, we are using matplotlib to plot this. And as if you remember in the last class, I said that, okay, we have imported a package matplot.pyplot as plt, and then if you give it plt.var x comma y, because it needs the x values as well as it needs the y values, and then you get a frequency distribution. And this is the graph of, so now you have done a lot of text analysis. Okay, so this is basically your simple. So we have not yet used the machine learning algorithms, but even without using it, you have got some really interesting results. So just by doing pre-processing and doing some part of speech tagging, lemmatization, stemming, and entity recognition, these are some of the higher level concepts, you can find some very interesting results. Okay, and same things you can do it for sentiment analysis. So this is, I wanted to share this with you. And then let me quickly go back to our presentation before I start with. Now we have done the pre-processing steps. We got some interesting results. Now let's come back to our steps in machine learning, because if I want to take this as example and then train my model. So basically, this is just a recap of the first class, that how you implement machine learning algorithms. You train the data by splitting the data into two parts, training set and testing set. It is generally done as 70-30 or 75-25. Sometimes you get training set and test set, especially in competitions. You get them separately, and then you build a model, and then you test your model on the test data and compare it with the actual values. And I have already shown you how this is done in the first class. And then you find the accuracy of the model. If the accuracy is very low, like less than 50%, then you may want to revisit your model, make some changes, and see if you are getting a better accuracy, or you may want to change the algorithm. So this becomes your last step. So that is what we are going So pre-processing steps we have done, analysis of a text file we have done. Twitter data I'll take, I'll just see, we have time. Now I wanted to do this text classification. I will show this example to you. If you don't understand it, don't worry. It's just to give you an idea about how we do text classification. Means if you want to classify into whether it's a document or it's a travelogue, or if you want to classify your text in different categories, then how it is machine learning is used. And then let me take this use case. Let's go through it. And it's a example from a website, and they have used text analysis. They have used Twitter data. And the problem was they analyzed the Twitter data with hashtag Brexit. And the tweets were related to the tweets they monitored were after UK decided to leave European Union, and how they reacted to it. So they analyzed around 450,000 tweets, and all of them had hashtag Brexit. So they analyzed those tweets, and they used some algorithms and keyword extractions. So they got these insights. And as you can see, green represents the positive sentiment and red represents the negative sentiment. And as you can see, the more people were against, and there is a high number of negative sentiments in those tweets. And then, so they analyzed the positive tweets, and they found out these were some keywords, the top 10 and the top 8. So thanks, the positive tweets, 7.5% people gave thanks. So result was a good thing, celebrating the independence of the UK. So these were some of the keywords which came out in the positive tweets. In negative tweets, people were disappointed. And if you can see, they have used that in negative tweets, people were trashing politicians. 48% were more negative, were basically writing against David Cameron. And there was a pro-Brexit politician. 272% tweets were directed towards, they were more negative tweets for him than positive tweets. So this is how they got these interesting results. So it's a use case of text analysis. So some of the most well-known analysis. So text analysis, you can do sentiment analysis, whether whatever text is, the sentiment of that particular text is, whether it's a positive, negative, or neutral. Then topic labeling is basically what is the customer organizing it by topic. Language detection, whether which language the text is about. And then the example is you route support tickets based on the language where it is coming from. Intent detection. So it's very useful for customer conversations, whether by taking a look at the text the customer has written, whether the customer is interested in the product or not. Now, all these things are basically when you collect the data and then you assign values. So it's not a straightforward process. All these things take some kind of pre-processing or data corrections. Okay, so these are some of the things which you will be seeing it. Now, it's not the end of the class. Okay, so we will, what I'm going to do, I'm going to again go back to my files and see if we can, let's see the programs. Let's do a new share. Let me share my screen again. So let's go to another file and where I will actually show you machine learning. And as you can see in machine learning, so this is the file where you are doing text classification, and the uh, scikit is the machine learning package. And you will see there are some things which are used here. It's a data from 20 news group. It's come pre-packaged with scikit library. So you don't have to download it explicitly. And as you can see, there is a training set. Okay. And first we will work with training set and then we will work with a text set. So basically a text file, if you, what we do is we make extracting, the first step is extra. If you remember, we first step was in machine learning was to read the data, clean the data, and then extract features. So we are doing extracting features. So this is the process for extracting features. And then you are going to use some algorithms. And one of these algorithm is native Bayes algorithm. So what we do, we tokenize the data, we make it into a matrix. So the text is converted into math, basically quantitative numbers. So there are ways of doing it, and one of them is document term matrix, where you extract the features and then you write how many features are there. So there are a lot of math goes into it. And then we are using one of the algorithms, and this is called native Bayes algorithm. So, so again, a lot of things are going on. You are using this native Bayes algorithm, calling it, and then you are using it on your training data set. Then you make do some processing, and then you are trying to test it. So this is the third step. Now, a lot of math and a lot of you have to know about these algorithms. But the best part is using is not a very big issue, because as you can see, everything is implemented in Python. You just need 2 or 3 lines of code. You have to just know the syntax, the correct way of using these algorithms, or calling them or importing them in your program. Okay. So we did it. We now applied it on our test data set. And as you can see, it predicted. So machine learning algorithms are step one is step three is make the model, and then you test it. So we tested the model on our test data set. And as you can see, we saw this value is 77.3. So basically my model is 77.3 times correct. Or in other words, you can say my model is 77.3% accurate, which is not a bad number. But you can use more algorithms, and one of them is support vector. So you can do a grid search, and then there is some another algorithm which can be used as support vector machine algorithm. So by using 2 or 3 algorithms, you may want to check which one of them is giving you more accuracy. So this is how your machine learning algorithms can be applied to text analysis. But if you want to do, don't want to go too deep into that, then I would suggest that even pre-processing steps, finding that will be a good idea. Okay, so let me see if I can. find another. And then this is a Twitter sentiment analysis. And I wanted to show it to you because you can make a word cloud out of it. So this is a Twitter data. And as you can see, we did, it's a simple, it was a CSV file, so it was not a big problem. CSV files are easier to handle. So we didn't have to convert them into lower or upper. So that was the best thing. So as you can see, it's about airline sentiment. So the tweets were about different airlines. Okay, and this is a Kaggle data set. So by getting .info, if you do it, you get the number of columns as well as what each column has the data type. And as you can see, confidence, they have given some numbers, whether it's a positive confidence or negative. And then so this just gives you the top 5 tweets, count of tweets. Okay. So this is JetBlue News had 23 tweets, and then it's followed by some other, basically the persons who were posting. Okay, so you can make the maximum number of tweets were 63 by JetBlue News, and minimum was 1. And then you plot it. And the interesting thing is about, okay, I don't see a word cloud. There is something which is called word cloud. Let me see if I have that. So that is what we did. Okay, yes. Now there is something called word cloud, and word cloud is you must have seen it in different. It's a very nice pictorial way of representing the keywords in your data, and this is something very interesting. You have to download a package called word cloud. So I did that, and then I made on the word clouds. Now this is if you the same Romeo Juliet .txt file was there. As you can see, the bigger the word, that means its frequency is highest. So as you can see, the smaller the word, that means its frequency is lower. Now I just made this word cloud on the data set, which was not even, the stop words were not removed. If the stop words were removed, okay, so I made it on the final text which we got, which had no punctuation and anything. So it's a very easy thing. It's a very interesting way of representing, summarizing your data. Word clouds is an interesting way of doing it. So just as for fun, or because it's just giving you, okay, these are some of the words, the top words, which are the biggest numbers. That means they have the highest frequency, and the smallest number, smallest word shows the words with the smallest frequency. So this is an interesting way of representing your text data, making a word cloud. So we have, let me show you meanwhile, let me see if my presenter is here. Yeah, I'm still waiting. So let me show you a very interesting demo of text analysis. And it's by IBM. And you can see the website. It's Watson Natural Language Understanding. So this is the website where you can type, I will take you to view demo. If you click view demo, you will go to this site. And as you can see, they have given you some text, demo text, which they have already given it to you. Now you can, if you click it, analyze text, you'll see a lot of things at the bottom. So corporate governance committee, organization. So basically entity recognition, which I mentioned. that named entity recognition is something which can identify the organization, names, or places. And it also, so as you can see, it recognizes that Directors and Corporate Governance Committee is an organization with 80% confidence. And then IBM is a company with 100% confidence, because IBM, it matched it with database and it can right away say that, okay. So this is entity recognition. Then let's see if there are keywords. So IBM Board Corporate Governance Guidelines. So basically this is a guideline which they entered as input text. And then part of, you can see there are directors, 68, there were the keywords, 68% relevance. Then ongoing basis is 58% relevance. And they have, there so many words are there and they have given its relevance and the percentage of its relevance. Concepts, let's see, score, corporation management, they have given you. Let's see the classifications. So as you can see, classification, and they have done the sentiment analysis. So if I click the first tab, all you, I'm assuming you all can see it. So entity sentiment scores. So positive is 72% of the times, then they have given you different text and they have given you its positivity rate. Okay, full document is 72% positive. So they have given it a score. And let's see what they have given the emotion. Sadness is very low, joy is 32%, fear is 3.7%. So basically, that's interesting that they have scored it by emotion. And as you can see, the emotion of joy is 32.41. So overall, this document is more geared towards happiness. And then the entity emotion scores. So they have now segregated or classified into by entities. And then they have given scores to entity also. Okay, so again, it comes that corporate governance committee, the joy is 15.76%. And as you can see, so this is interesting because you can try your own input text also. Just copy and paste here, and then you will see what exactly you get. So this is something which is worth exploring, interesting, and you can always play with it. And if you remember in the first class, I had given you Microsoft and Google website where there are multiple demos on text analysis. So this is the time when you may want to revisit those sites and see and try to understand those examples in a better way. So I hope I have Nishi with me. So let's, Nishi, you are there. So start sharing your screen, please. So we have Nishi. So the next is our student presentation. Nishi is joining us from New York, and she has done a project under Visor for text analysis, and she's going to present that to you. And you will be able to see how she has used the different concepts of text analysis and applied it into her.
It says screen sharing is disabled.
It says, okay, let me stop sharing and then I will allow you. Okay, now you can do it.
Okay. Okay. Sorry that I'm on the wrong side. So my project was teaching kids writing skills using natural language processing. So the objective of this study was to see if we could use natural NLTK, the toolkit, and natural language processing to help children ages 5 through 8 to improve their writing skills. So the way I was able to collect these writing samples was during the quarantine. I there were 12 kids enrolled in this summer camp I was running, and it was based on creative expression. So the camp summer plays had 12 kids, and I was able to gather 12 writing samples, one from each kid. And they were all either handwritten or typed. And as I said, as mentioned earlier, the main objective of this study was to see if I could assess these kids' writing samples using a machine and not just using my own human insight. So before the procedure could be started, the samples, which were handwritten because not all of the kids could necessarily type since they were 5 to 8, they had to all be typed up in their original forms. So I couldn't really alter their punctuation, their vocab, or any misspellings, because then you wouldn't really be getting a true sense of what they wrote. And after typing up all the samples and making sure everything was functioning, the first step was pre-processing, which is where on Jupyter Notebook, which is where I ran the program, I had to make sure that I had to make all the words lowercase. I had to tokenize the whole writing sample, which is when each word in the writing sample is put as its own string almost. And the reason, and also I had to root out all the stop words. And stop words are basically like not unnecessary words, but like fluff words like and, but, stuff like that. And the reason I had to take those out was because if I kept those in, I wouldn't really get the true meaning of the samples, and it would kind of distort the meaning. So this whole pre-processing stage was mainly there not necessarily to get the meaning of the text, but to make it easier for me to, in the next steps, get the meaning of the text. And so the first actual function applied to analyze the text was imported from the NLTK library, or Natural Language Toolkit, and it was frequentist. I'm not sure if I'm pronouncing that correctly. And that was mainly used to see the frequencies of certain words. Like, it would tell me the top 10 words a kid was using in their sample, the top 20 words. I also applied a function which would tell me how many words the sample had. And when I'm saying how many words the sample had, I'm saying when it doesn't have stop words. And it would also tell me the number of unique words. The number of unique words is basically, it counts the first time a word is used. So then another function that I used which was especially valuable, actually, which actually helped me get a lot of important results, was speech tagging. And speech tagging labels all the individual tokens or words used with certain codes that corresponded with different parts of speech. So it would go through all the non-stop words, all the tokens that I had rooted the stop words out of, like the processed text, and it would tell me what part of speech each and every word was. And using this, I could actually go on to make pie charts and collect data of what percentage, like, is this 20% verbs? Is this 20% nouns? And it'll be shown in the next slide. And finally, a final function that I was able to use was the lemmatizer, which grouped all the different forms of a word into one main form. So kind of like one kid had an obsession with washing machines. So he would constantly talk about those. So there was washing, there was washer, there was wash, and it would put all those words under one like main umbrella, so to speak. So like it would group it all into wash. So these were some of my findings. So I'm only showing the two results of 2 kids because I think these 2 kids have pretty interesting results in particular. And the kids' names have actually been changed so to avoid like issues with privacy. So all these codes that I wrote, these letters like NNS, NNP, JJS, JJ, they all correspond to a part of speech. So NNS, NNP, and NN all have to do with nouns. All the V's have to do with verbs. And JJ has to do with adjectives and adverbs. And this is a word cloud of all of their top 20 words. And it's interesting because, as I'm going to get into it in the next slide, there were some repeat words. Okay. So, one interesting finding was that while the kids in general, like of the 12 kids, I would say most of them had pretty distinct groups of 10 to 20, top 10 to 20 words. The two kids that I showed, there were actually three other kids who had this thing, all had the word government, center, and world in their top 20 words, which was interesting to me because these kids were like maybe 5 to 7. So I have a feeling that it's most likely because of their interactions with each other. And in general, those 5 or so kids tended to be the most close. So it's possible they learned from each other, which could be seen as a limitation of this study. Most of the vocab words used by the kids seem to be age appropriate. Obviously, like words like government were not very age appropriate, but not in like a bad way, I guess. And the top 20 words, not only did it show me like the vocab skills of the kids, it also showed me if the kids addressed the prompt. So the prompt I gave them was, tell me about an adventure you have. It was pretty general. And some of these kids really did not address the prompt. Their top 20 words, like if we go back here, when they say stuff like um they would switch focus midway through. Like this one kid had the word bear, the word tree, and then they had the word machine, and then they had the word world. So it's kind of obvious that there was some sort of weird switch in focus some way through the text. And another thing was that I found that while kids mostly tended to use a lot of nouns, like I would say they use 40% or so nouns, when the kids used verbs, they tended to use a lot fewer adjectives. And it actually happened vice versa as well. When they used a lot of adjectives, they didn't use that many verbs. So that to me basically says that when they wanted to write a more action-packed story, they sort of did that and they let go of trying to describe things. It was just girl did this, girl did that, girl did that. And that also ties into the whole thing about staying on topic. Because of all the varied words, and I guess they wanted to fit in as much adventure as possible, it didn't necessarily always address the prompt. It didn't really give you a good idea of what was going on. And so VBG, or passive voice, was used needlessly by the kids. Passive voice is when it's like the boy hits the ball, or but something where the action, whereas the boy is hitting the ball. Like the boy hits the ball is kind of not as sensory detail wise and as, I guess, action packed and it isn't as, you don't have as much of a connection to the text when someone would say the boy hits the ball. And that's something a lot of the younger kids especially struggled with. They, even when they had more action packed stories, they tended to use a lot of these passive verbs, which I found to be interesting. So my overall experience was that some of the challenges were that some kids didn't write enough to judge in a way that's fair. Like some kids would write maybe 200 words, and that's not really enough for me to judge. And the age range was a lot more drastic than I expected. Like I didn't expect to see such a huge difference between the writing quality of a 5-year-old and the writing quality of even like a 7-year-old. And sometimes that was a little bit hard to navigate because you can't really have the same standards for someone who's entering kindergarten and someone who's entering second grade, because there's so much development which happens between those 2 years. And I often, when it comes down to actually the coding process, I often ran into a lot of syntax errors along the way. But there were definitely things I really liked about the process as well. I really liked being able to alter the code to reflect each kid's unique abilities, which is how I was able to get over the age road bump. And I also enjoyed finding ways to connect some of the more limiting functions like word number, word count to some bigger ideas. Like I didn't mention this, but word count, for example, if it told me the number of unique words, and let's say it was like 500 words and then like maybe 450 unique words, something like that actually happened. That tells me that the kid can't really stay on topic or stay with an idea for a long period of time. And it's cool to see these writing connections with such intricate code connections, I guess. Thank you for watching.
Thank you, Nishi. It was a very interesting project you did, and I hope you will keep on applying what you learned in some other way also. So thank you. And so you can stop your screen sharing. Okay. So let's come back to the last part, and that is thank you from my side. And if you have any questions, you can always contact me at my email ID. I can see a chat. So, um, so next week we will be doing creating chatbots using Dialogflow. So just to give you a little bit information about chatbots. So virtual agents or chatbots, you may have encountered them while visiting a website to get the general information about the site. Okay, so they are becoming a very popular choice because uh, you don't have to scroll down different sites or different web pages just to get information. You can right away type your query and you can get the results. So with especially with shops, it's not always there are not always people to respond to your queries, so they are available 24 by 7. So this is becoming, and it's a very interesting because we will not be doing any kind of programming. In Dialogflow, you don't need programming. It's already an infrastructure. It's a platform which is there. You just have to use your logic and we'll start designing a chatbot. Okay. And we will implement it. You can always, it's a free service. So you can you can work with me while we are making these chatbots. So see you next week. And I hope you enjoyed the class. Thank you, Nishi, once again. Okay, see you in the next class. Bye-bye.